Hi students, in this video we're going to simplify expressions with integer exponents. So first, just a quick review of some of the properties related to integers. Now, first of all, a power written in the form a to the n, where a is the base, n is the exponent, simply means to multiply a by itself n times. Okay, so that's your basic concept for an exponent. A to the 0 power, just to list a few properties, a to the 0 power equals 1, and a to the negative m power. Now that is the reciprocal of a to the positive m, so the reciprocal of a to the m is 1 over a to the m. So a to the negative m equals 1 over a to the m. Another property related to negative exponents, a to the negative m over b to the negative n. Now notice a to the negative m is in the numerator of this fraction. We can write a to the positive m in the denominator. That's the same thing as saying 1 over a to the m. B to the negative n is in the denominator, so b to the positive n will end up in the numerator. So one easy way to think about this is if you have negative exponents, all you have to do is move from the numerator to denominator and change the exponent positive. Or if you have a negative exponent in the denominator, that power moves to the numerator and it becomes a positive exponent. Okay, a few other properties real quickly, just to refresh our memory here. A to the m times a to the n equals a to the m plus n. Okay, that's called the product rule. A to the m divided by a to the n, where a to the n is not equal to 0, is equivalent to a to the m minus n. It's actually just a not equal to 0, so where a is not equal to 0. So a quotient of powers, you subtract the exponents. That's called the quotient property. Next, a to the m raised to the n. This is a power of a power, equals a to the m times n. Okay, that's called the power rule. Another property, ab to the m, a to the m, b to the m. That's sort of like distributing that exponent. Okay, that's called raising a product to a power. And then a over b to the m equals a to the m divided by b to the m, okay, where b is not equal to 0, because you can't divide by 0. That is called raising a quotient to a power. So the last two are sort of like distributing that exponent. And then sometimes you have to do more simplifying. So let's do a few examples here. So first it says simplify 8a b to the 7th times negative 7 a to the negative 5 b squared. Okay, now we're multiplying. You should first check to see if there's any exponents outside the parentheses, and there are none. I don't see any exponents outside the parentheses. So we can actually use commutative property and just rearrange all these. So we can do 8 times negative 7. We can do a times a to the negative 5th, and we can do b to the 7th times b squared. Okay, now remember, over this first a, there's a 1 there. A by itself is a to the 1. All right, 8 times negative 7 equals negative 56. Now here we have a to the 1st times a to the negative 5th. We're multiplying two powers with the same base, so we subtract the exponents. 1 plus negative 5 is negative 4. So we write that down. Same thing with the b's. We add the exponents and we get 9. Okay, so b to the 9th power. All right, now notice we have a negative exponent. So we're going to write a fraction bar. The negative 56 stays in the numerator. The b to the 9th stays in the numerator. And the a to the negative 4 gets written as a to the 4th in the denominator. And then just to clean this up, you can really just write this whole fraction as negative. So negative 56 b to the 9th over a to the 4th. Okay, another example. This is an example where I would simplify first and then deal with any negative exponents. So notice you have 20 a to the 5th b to the negative 2 in the numerator over 5 a to the 7th b to the negative 3 in the denominator. Now, it's nice that we have everything pretty much lined up. The 20 over 5 is lined up, the a to the 5th over a to the 7 is lined up, and the b's are lined up as well. If it's not like that, you might want to line them up first. Okay, so 20 divided by 5 is 4. Now, the a's, we have a quotient, so we subtract the exponents. 5 minus 7 is negative 2. The b's, we subtract the exponents. Negative 2 minus negative 3 is like negative 2 plus 3, so that's to the first. Alright, and we have one last step to do. The a to the negative 2 will move to the denominator, become a squared. 4 and b will stay in the numerator because they have positive exponents. You only move anything with a negative exponent. Okay, and one final example. This looks very complicated, but the very first thing I would do is I would simplify inside that fraction first, inside the parentheses first. So let's do that. 125 divided by 25 is 5. P's, we subtract the exponents because it's a quotient. 12 minus 8 is 4. The q's, we subtract the exponents. Negative 14 minus 6 is negative 20. And then the r's, we subtract the exponents. 22 minus negative 15 is like 22 plus 15, so that's 37. Then we still raise it to the negative 4. I'm just doing my work off to the side there. Okay. Now, I wouldn't make another fraction yet. See the q to the negative 20? You could write it this inside the parentheses as 5p to the 4th r to the 37 over q to the negative 20. I would actually give each of these factors inside the parentheses the negative 4 exponent. And I take one extra step and I write it out like this. Sort of like distributing that. Now what I'm going to be doing is I want to multiply any of these exponents first. The 5 to the negative 4, leave these by themselves until you actually get rid of all these parentheses. So now p, we're going to have 4 times negative 4, that's negative 16. Q, negative 20 times negative 4, that's positive 80. And then r, I need to go off to the side and do that multiplication real quick, but 37 times 4 is 148, but it's going to be negative. Okay, now, anything with a negative exponent is really 1 over that same base with a positive exponent. For example, the 5 to the negative 4 is really 1 over 5 to the 4th. So I'm going to write a fraction bar right now. There's only one power that has a positive exponent. That's the q. Everything else is going to go to the denominator, but that power, the exponent, is going to change to a positive. And then to truly simplify this, we should do one last thing. We should change the 5 to the 4th power to what it is, 625. So q to the 80th power over 625, p to the 16th, and I changed a letter here. So let me go back and change that to what it should be. That should be an r. to the 148. Now all exponents are positive, and there are no like bases that we can combine. Okay, if you have any questions, please contact me as soon as possible. This was Al Drusler.